video is this video is for homework 6, and this is the first question in homework 6. In the first question, we get the x and y's joint density function, and in the first question we have to get the a's value. To get a's value, we have to integrate the density function, and the result should be equal to 1. As we getting this, we can finally find that the a is equal to 4. And in the second question, x, y are uncorrelated. And since we need to find the x, y's expression, their mean, and we use the integrate to find their mean is equal to 1 divided 9, and also we need to find the expression of x, the mean of x, and finally we found that the value is equal to 0, so we don't need to calculate the y expression. And since the expression of x multiply y minus the expression of x multiply the expression of y is not equal to 0, so the x, y are not uncorrelated. And since we get the result of question 2, the x, y are not uncorrelated, so we can easily to find that x, y are not independent. And so we are going on to the question 4 in the first big question. And in this question, first we need to we assume two new parameters, z and omega. And first we let the z equals to x square and omega equals to y square, and we can use the Jacobian equations to find the relationship between the z and omega, and the Jacobi equation is the final result of the Jacobian is the 4 multiply x multiply y. And since we know the relationship between x and y of z, and the relationship between x and z, and also we know the relationship between the y and omega, we can use the formula that using the joint density of x, y divided the Jacobian's value, and finally to calculate this, we can get the z and omega's joint density, and since we find the result, we can using the result to build the density of the joint density function of z and omega, and also we can get the mass function by integrating the joint density of z and omega, and finally we can find when z I'm sorry, we need to find the density function of omega, and we integrated the joint function of z and omega by z, and we can find the density function of omega is the result in my paper, and also we can use the same theory to get the z density function. So finally, in the final question, we need to prove or disprove that square of x and y square are independent. Since by calculating the question 4, we can find the joint density of z and omega are equal to density function of z multiply the density function of omega. So we find that they are independent. So this is all the results and my analysis in question 1. Thanks.